Hello, in this video, I will explain to you on how to solve this problem, number 24. In the 1991 World Track and Field Championship in Tokyo, Mike Powell jumped 8.95 meter, breaking a full 5 centimeter, the 23-year-old long jump record set by Bob Beamon. Assume that Powell's speed on takeoff was 9.5 meter per second, about equal to that of a sprinter, and the G is 9.8 meter per square seconds in Tokyo. How much less was Powell's range than the maximum possible for a particle launched at the same speed? Okay, so remember that we need to calculate the distance of this particle here launched at maximum possible range. And maximum possible range usually meaning that this alpha here is 45 degrees. So the launching of the particle has the angle of 45 degrees. And now we assume that this particle has the same initial velocity, which is 9.5 meter per second. Okay, let's write that. So we will have its initial velocity here. That will be our VO. And that VO is 9.5 meter per second. And we can break it down into horizontal and vertical initial velocity, right? So we will have this one here, VO, X. And this one here, vertical initial velocity, VO, Y. And we can just calculate that. What is VO, X here? VO, X. That will be VO cosine of alpha. But then VO, Y. That will be VO sine of alpha. Let's plug that in. VO is 9.5 and alpha is 45 degrees. So I have 9.5 cosine 45 degrees. And this one will be 9.5 sine of 45 degrees. And that will be, okay, let's use calculator for that. 9.5 multiplied by cosine of 45. Okay, and I will have 6.72. 6.72. And the unit here will be meter per second. And this should be also the same, right? Because sine and cosine is the same. Let's see here. It is the same. Sine 45. Yes, it is the same. So I will have 6.72 meter per second. Now we are interested for the particle in this initial position and this maximum height position. Why? Because we can calculate the time when it is going up here. Right? So when the particle is going up, okay, and the particle will have the acceleration by the gravity, right? So it will slow down by the gravity. So I will have this A here is equal to minus G, and that will be minus 9.8 meter per square seconds. But then we can just use this formula here to calculate the time. Vt is equal to VO plus AT, right? Because the particle is going up and then going down, here in the maximum height, the vertical velocity here will be 0. So Vy here will be 0. So now we know that Vt here is 0. But the initial one is 6.72. And then the acceleration is minus 9.8. So I have minus 9.8 multiplied by t. That t is t when going up. Right? So I will have 9.8 and t going up is equal to 6.72. So we will have the time the particle is going up. That will be 6.72 divided by 9.8. And that will be, okay, let's calculate that. 6.72 divided by 9.8. And that will be 0.69. 0.69, and the unit here will be in second. Okay, but then the time going down here, because it is symmetrical to this one, that will be equal to the time that is going up, right? So the total time of the particle in the air, so I will have T total, is just 2 times the up, right? So 2 times the time it is going up, this plus that, so that will be 2T up. But then that will be 2 multiplied by 0.69, and that will be 2 multiplied by 0.69, and I will have 1.38 second. 1.38 second. And then we can calculate this horizontal direction, right? So we will have to calculate this x here. And x should be easily calculated. Why? Because it has constant velocity in the horizontal direction. So we have this Vx here is the same as the initial, and this Vx is also the same as the initial velocity. And all that will be 6.72. Right? So we can just multiply the speed by the time. And then the velocity here is equal to 6.72 multiplied by the time here, 1.38. And then that will equal to 6.72 multiplied by 1.38. And I will have 9.27. Okay, 9.27 meter. And we need to compare this 9.27 with 8.95. And the question is how much less? So we can just calculate the delta x here. So delta x is 9.27 minus 8.95. And that will be 9.27 minus 8.95. And I will have 0.32. 0.32, and the unit here will be in meter. And that is the final answer for this question. Let's highlight that with gray here, so we know that this is the final answer. Okay, and I think that's all for this problem. Hopefully, I did not make any mistakes during my calculation. Thank you for watching. See you in the next video. Bye-bye.